It's good to see you again, photography class. This lesson is on the basics of shutter speed. You'll recall that we did a basic lesson for aperture and how difficult that was to understand. This is not quite as difficult as understanding aperture. However, there's some math involved in this lesson that I encourage you to stop this PowerPoint presentation and really look at the numbers you're seeing on the screen and think about it, because I think once you take the time, as I did, I spent quite a while just sitting and thinking about the math, and all of a sudden it made sense. All those numbers I keep seeing in my viewfinder, I keep thinking, why aren't they easier to understand? And doing the math really helps to understand that. And just as the aperture lesson, we're going to be creating a personal chart on the shutter speed settings in your personal camera in this lesson. There is no photography in this lesson. We'll be doing that in the next lesson. We'll go out on location and do some filming again as in previous lessons. This one is just understanding shutter speed and creating your chart as your lesson. So to begin, what is shutter speed? Shutter speed equals exposure time. I try to put this in most easy few words to help you understand. So if shutter speed is exposure time is the amount of time the shutter stays open. Or you could just cut that straight down and say shutter speed is the amount of time that the shutter stays open. Now, the easiest concept for shutter speed is that the longer the shutter stays open, the more light it lets in. The faster it opens and closes, the less light is going to let in. EV, you may remember this. I don't know if we've covered it or not. I think we did. But EV, you'll see that in a lot of tutorials out there online and in books. That stands for exposure value, or it's the same thing as saying stops. So when we had f-stops for aperture, that was moving the exposure value up or down. So we also have stops. They're not called f-stops, but we also have stops in shutter speed. So you'll read in books and other tutorials, and I'm not going to get that deep into the math, but if you have the shutter, each stop of the shutter speed is halving it or doubling it. That is, each stop equals 1 EV more or less depending on which way you're going. The aperture also doubles when you move it per stop, up or down. So if you move one stop on the shutter speed in one direction, you move one stop on the aperture in the other direction, and it equals the same EV, or the same exposure value. So you want to get the same exposure value to have the best exposure. Remember, we said there's no perfect exposure, but when you look at the histogram, you want the one that is a good exposure. Well, if you want to maintain that good exposure, and you're going to maybe try to get a technique such as moving water that looks dreamy and blurry, and you want to get it at that particular shutter speed to get that, then you're going to have to move your aperture that many stops also, so that it equals the same exposure value. So you have the same good or best histogram. I'm hopefully making a little bit of sense. It's very complicated, but another alternative is to change the ISO. So you remember that tug-of-war triangle? I'm trying to reinforce that a little bit more here. Basic purposes of shutter speed. Short shutter speeds have freezing subjects, not freezing like cold, but like you stop them in action. So short shutter speeds, the one that go open and closed real fast, freeze a subject or make a moving subject sharp. Long shutter speeds blur the subjects. So if you want to blur the moving water so it's dreamy, you're going to choose a long shutter speed. If you want trailing lights on cars going down a highway, you're going to do a long shutter speed. In other words, you're going to leave the shutter speed open long so you capture those lights as they're moving along. So those are the basic purposes. Why are my photos blurry? Well, blurry photos may not be due to focusing. I mean, sometimes your blurry photos are going to be because you just did not focus it well, or you had it on auto and you took it off and put it on manual focus and you didn't quite focus it right, or I don't know, for some reason the autofocus didn't work. So blurry photos can be a focus because of focusing, but not always. Handheld shots, in other words, those not on a tripod, when you're holding the camera in your hand, capture the camera movement. Now, I don't know about you, but I cannot keep my hands perfectly still for a very great long period of time. The longer I have my hand out and I try to keep it still, the more chance it's going to move. So 1/60th, aha, this is our first figure. Just remember 1/60th. It's a good thing to remember, and we'll be reinforcing that here. But 1/60th or faster is general rule as okay for handheld. So if you're not going to be putting your camera on a tripod, in general, don't move your shutter speed faster than 1/60th of a second. And most likely that shutter speed is going to open and close fast enough that it's not going to capture your hands shaking or moving. Slower than 1/60th requires a tripod or other stabilization, such as setting it on a hard surface. I'm recalling I forgot to put this in the PowerPoint here, but stabilization is also on your DSL cameras. If you get a good lens, it's going to have something called stabilization on it. That is also something very important, and you probably don't ever want to turn that off. Another general rule. So a focal length of lens also affects camera shake. And now this is going to make sense, so hold on with me. If you turn that lens so it is longer, or you make it a longer focal length, or you zoom in, and your lens gets nice and long, it's going to be harder to hold it stable than as something that's smaller and more compact. Your point and shoot cameras that don't have those lenses that stick out are going to be easier to hold stable than even a DSLR lens that sticks out some. And of course, then if you zoom that DSLR way out, it's going to be even harder to keep it stable. So, going back to the first thing mentioned here, a focal length of lens affects the camera shake. Therefore, the longer focal length, you need a faster shutter speed. So if you zoom that out and your camera lens is really heavy now, and it's unstable because it's spread out. It's kind of like I can't think of something. You know, you're trying to hold a small stick out straight and keep it balanced straight. That's much easier than if you have a very long stick that you're sticking out. That is much harder to hold straight. And so the longer focal lengths, you're going to have to use faster shutter speed to adapt for the camera shake. General rule: use shutter speed at least 1 over your focal length or faster. So we saw earlier that 1/60th is the general rule that people have, that you can hold the camera steady at 1/60th or slower enough to not blur your images. Or this general rule is 1 over whatever your focal length is. So let's look at an example of my lens. My lens has a focal length of 28 to 135. So at 28, my lens is not zoomed in at all. It's all the way back. So if my lens is in that position at the 28 millimeter, I might be able to hold it steady at 1/28th of a second or faster. But if I zoom that out, oh, I have an error there. It's supposed to be 135 on each of those numbers. So 135 millimeter equals 1 over 135 or faster. So I cannot do that 1/60th very well if I zoom out to 135. So that general rule of 160 doesn't apply really anymore if I'm going to zoom my camera all the way out. I'm going to want to do 135 or faster in order to avoid that camera shake. These are all just some general rules. There's no right or wrong. It's just something to give you some guidelines when you're out there. And you're going to be able to see this a little bit more later. I actually have this in the chart that you're going to be creating for your camera. So now let's get into that difficult. I have to think. I don't want to think. Math. Okay, the bigger the denominator, the faster the speed. Now you're going to recall, hopefully, it's been a long time since I've done math. It's been a long time since I've done fractions, but in a fraction, the denominator is that bottom number. So when we had 1/60, the denominator was 60. So, as an example, 1/2000th of a second is much faster speed than 1/20th of a second. So the bigger the denominator, the faster the speed. Fast shutter speeds are considered around 1/500th or faster to freeze motions of fast subjects. That's just another kind of little general rule. So if you're trying to catch a sports photo or a freeze water so it's crystal clear, instead of the dreamy effect, you're going to want to try to go 1/500th or faster. Very slow is measured in whole seconds, and so instead of the 1/20th of a second, which would be fast, if it's 1 second, that's going to be slow because it's going to shay. I have no idea where that came from. It's going to stay. The shutter is going to stay open for a whole second if it's 1 second, but it's only going to stay open for 1/20th of a second if it's a fraction. so that these fractions are much faster and the whole numbers are much slower. You're going to see more of that. What you see in your camera, oh, this was the hardest part for me to grasp. So really, really, really pay attention, because I hope, and pause the video while you're looking at each of these things. I really hope that this helps you, because I did not see this presented any other way, and once I did it this way, it greatly helped me. So what you see in your camera and how to interpret it. If you see a whole number in your camera, it doesn't mean a whole second. I know, goofy. If you see a whole number in your camera, you have to think in your head it's going to be 1 / that number. In other words, if you see a 4 in your camera, it's actually 1/4 of a second, or 1/4 of a second. So if you see a whole number of 2000 in your camera, it's actually 1/2000th of a second. If you see in your camera a number with a quotation mark symbol, which also stands for seconds, it's going to be 1 second or higher. So if I see a number in my camera that says 1 and then the quotation mark symbol, also known as the second symbol, if anybody types legal descriptions out there, you know that they use the quotation mark for the seconds in legal descriptions also. But if you see oh, well, here's my sample. If you see 4 with the quotation marks as opposed to this 4 without quotation marks, it's going to be actually a whole full 4 seconds. Say that 5 times fast. Full 4 seconds, full 4 seconds, full 4 seconds. So stop this and look at this for a bit. Get this in your mind. Stop the video and study this for a minute. Get this in your mind. This is so important. This is what is so, gets to me. Took me the longest time to understand it. So if we have a whole number, you automatically think of it as in fractions with the 1 over the top. If you see it with a quotation mark, it's actually whole seconds. More math for faster speeds. This is how we're going to do the math to help you understand better. Let's convert some figures into whole numbers with tenths after the decimal points. You'll remember that if you have 1.1, that's 1 1/10. Anything after the decimal point, we speak of it as tenths. So we're going to convert, whoops, let me go back the other way. We're going to convert both of these into types. This first one, for faster speeds, into whole numbers with tenths, and we're going to convert this second type into whole numbers with tenths. So we have a whole number in your viewfinder which represents a fraction. It's not really a whole number, it's a fraction. It's the number you see is actually the denominator, or the bottom number of 1 over the number. As we just saw, a 4 in your viewfinder is going to be 1/4. And to make 1/4 a whole number with tenths after the decimal point, divide the top number by the bottom number. So we're going to have 1 divided by 4, which is 0.25, or it's 1/4 of a second, or it's 25 tenths of a second. So we have just taken the fraction, which looks like a 4 in your viewfinder, but represents a fraction, and converted it to a whole number, which is just 0.25 tenths. Hope you followed that. Now the math for the more slower speeds. You have to think about them differently. It took me the longest time to figure this out. Slower speeds. Now they are the ones with the number and the seconds or quotation symbol, are calculated differently to convert to whole numbers. The number you see is not the denominator, it's the numerator now. The numerator in that it's the top number over 1/10. In other words, it is a figure in tenths. And now we can get a little further and you're going to stop this video and study this page again. And it's all going to make sense. So, 4 with a quotation symbol is the same as 4 seconds. It's not a fraction. It's already a whole number. So this isn't going to be a good example. So we're going to give you another example. 3 seconds and a 2 equals 3.2 seconds. If you speak this number, it is 3 and 2 tenths. Alternatively, it is 3 and 2 over 10. So if you go back up here and look, this 2 here is going to be over tenths, which is what I've set up here. It's going to be a numerator. It's going to be the top number over the tenths. So it's going to be 2 over tenths, whereas before it was the denominator. Okay, go ahead. Pause the screen, read this 10 times till you understand it. Okay, do you have it? I sure hope you do. If you have to, go back and watch the first part again. Math comparison. Here's the 2 types right beside each other in some common, easy to understand figures. We've reviewed this one a lot. I've picked on this one because it's easy to understand. We all know a quarter of something is like something divided it into 4 pieces of a pie, and you get one of those 4 pieces, or a quarter. So, for the faster speeds in the viewfinder, it looks like a 4, but you have to think in your head it's really 1/4. The 4 is the denominator of 1/4. And if you divide 1 by 4, you get 0.25. Or you get 0 seconds and 25 tenths. Now for the slower speeds, here's a common one. You have 0, quotation 5 in your viewfinder, which is the same as 0.5, and it's also the same as just 0.5. What is 0.5? It's a half. So you have your pie and you divided it in half, and you got 2 pieces and you eat 1. Common, easy to understand. So in this case you have 0 seconds and 5 tenths. Now which one is faster? It would be the 0.25, because it only stays open a quarter of a second, whereas the other one, 0.5, stays open a whole half a second. Okay, pause the video, look at this, and think about it. These are the 2 different ways you're converting and doing the math. Here is my chart. I have my camera lens down here, 28 to 135 millimeter, and these are all the shutter speeds I can get. Isn't that amazing? But let's observe some of these. In general, the long or slow shutter speeds are on the left, Those are the ones for blurring subjects. And in general, the short, fast shutter speeds, ones for freezing subjects, are on the right. Now I say in general because actually this goes top row and then back to the left. So 4.4 is actually a slower speed than 0.3. 0.4 is slower than 0.3. 0.04 is slower than 0.03. Or, well, if we go the top number, 25 is slower than 30. The top number in red is the number I'm seeing in my screen. The bottom, the number inside here, that is my math conversion that we've just done to help me see which ones are easily see which ones are faster and which ones aren't. So obviously something that's 30 whole seconds, that's a half a minute. My camera shutter stays open a whole half a minute, is going to be a much longer speed than something that stays open a 0.10 of a second. And 0.10 of a second is going to be something that stays open longer than a 0.8, and you can see these numbers go progressively down. If you look here, here is the dividing point between 4 and 0 seconds and 3 for my particular camera. So when I look at this 4, this is the example of the one we've been doing throughout this lesson. When I look at this 4, I immediately think of it as 1/4. When I look at this one, it's 1/5, 1/5. When I look at this one, it's 1/6 of a second. And so when to get this figure here, I'm going to divide 1 by 5 to get 0.20. I'm going to divide 1 by 6 to get 1.17. So from here this way, where you see the whole numbers, that's how I've got each one of them. I divided that number into 1. From this way forward, you have to look at it the other way. This is 0 seconds and 3/10. So now the 3 is a numerator, it's on top. This is 0 and 4/10. Now the 4 is on top as a numerator over tenths, and so forth. Here is 1 whole second, and here is 1 second and 3/10. So I think you're beginning, hopefully, now that you see my chart, to understand the math and understand why I'm doing this way, because it really helps to me to make more sense. If I look at something in the viewfinder and I see 1000 and then I look and see 13 second, I just can't get it. But if I look and say that this is 13 whole seconds and this is 0.0010, I get it. This is much faster. So for me, it helps to convert them, and hopefully it helps you to understand a little bit better also. Now, what are those circles? You're going to recall we talked about for handheld shaking that in general, a general rule is 1/60th second. Well, that would be this 60 here. So right here is in general something if I don't have a tripod, I'm not going to try any of these speeds here without a tripod. Any of those up on the top. Any of them faster than that. But without a tripod, I can try any of these below this because they're faster than 1/60th. Okay, now our second general rule is the other two circles. So my lens is a 28. We went over that. So if I do 1/28 or faster, well, I have 1/25. The next faster is 1/30. So this is going to be the first one that's faster than 1/28. And so if I have my camera all the way in, I might be able to hold it steady here. Of course, that's a little ways down from that 1/60th general rule. So, there may be some play in here, but I don't know. I'll have to play with my camera. But I definitely don't want to go lower than this. And on the 135 millimeter, so if I look 1/135, well, I have 125 here, so I have to go one more up to the 1/60th. So for my 135, to get something faster, I have to do this 1/60th. So if I zoom my lens out, I don't want any speeds faster or slower than this 1/60th. I can go faster, I can go this way, but not the other way unless I have a tripod. So that's what those circles are for. I find those very handy. Actually, I was going to I didn't do it, but maybe I'll go back before I share it. The 500th here, or faster, is considered for fast shutter speed. So if you're trying to get a sports photo, you're going to want 500th or faster. That doesn't leave me too many here in comparative of the whole chart. Okay, this is my point and shoot. Now, I must admit there was really no way for me to look up in my point and shoot the shutter speeds. I actually went online and looked up the name of my camera, shutter speed, and specs. And actually I found two sites that said my camera went from 1/4 to 2000. And I had one site that said it went from 4 seconds to 2000. So somebody didn't get the website right and another website copied off of them, because I went ahead and took a variety of photos, and I actually found there was a fireworks setting on my photo, on my camera, and it took it at 2 seconds, which is much faster than this 1/4 that some of the websites said. So I knew after that I knew which which website was accurate. And so if I got it to go to 2, it probably is going to go to a full 4 seconds at some time. The sports photos were coming out right at 500, but the website said it goes up to 2000, so I'm not sure how to exactly get it to go there, but this is how you're going to have to do it for point and shoot. And then here we go, we have our 5, which is 1/5, and if I want something, we have that here, but if I want something faster in general, zoomed all the way in, I would want 6, and 25, something faster, would be 30, which both of those are faster than the 60th general rule. So go figure. But you know what? That camera is very light, and it might be much easier to hold without shaking. Bulb mode, and I probably need to go back and change my thingy. Let's see if it'll go back. Right here, well, back one more. Right here on this 30th, if I keep going down on my speeds, I get to bulb right here. It's going to be not at this end, but it's at this end on the slow speed, so I might go back and stick that in my chart. Bulb mode is only on the DSLRs, and it holds the shutter open for as long as you hold down the shutter button. So I can actually get, and the reason why it is up there on this end is because I can actually get a shutter speed slower than 30 seconds, because it's going to stay open as long as I hold my little old finger there. And that's what the bulb mode is. Panning. Now we're going to get into just talking about a few fun techniques. They may come up in future lessons, so don't run out and maybe do these right away because they may come up. But just to get you into understanding a little bit more about why you might want to use that shutter priority, which is TV on your camera. Panning is following the subject as it moves with a slow shutter speed. So in other words, you're actually moving the camera with the subject as the subject's moving. 1/30 and 1/60 are common and uses for the panning and to get a sharp object against a blurred background. It's a difficult technique but kind of fun to practice. Architectural moving subject. A slow shutter speed while taking photos of a building blurs out or makes unrecognizable the subject moving in front of the building. So if you have a person walking in front of a building, well, the building's not going to move. So if you use a slow shutter speed on a non-moving object, it's not going to change that object a whole lot. But if you got somebody moving in front of it, it's going to blur them out to make them unrecognizable. Kind of a handy technique. Streaks of light. Oh, we're going to do this for a lesson probably. Shutter speeds between 1 and 15 seconds at night with lights of vehicles. Of course, you could try 20, 30, 40, no, 40. You can try any shutter speeds, but we're talking the slow shutter speeds at night. You go out to a bridge or a highway and where you have lots of cars going. I know you've seen these photos on the internet, and the cars have these streaks of lights coming out from underneath them. Slow sync flash, where actually I practiced and I have this on my camera, so I will be doing a video lesson of this. But a slower shutter speed with flash of light to freeze the subject. So this is using your flash with slow shutter speeds. Now, on my DSLR, I do have a setting for front curtain and rear curtain. The front curtain makes the flash go off at the open of the shutter, when the shutter opens. So the shutter opens and it flashes, and then your shutter stays open for a long time and closes. A rear curtain, the flash is at the end of the open shutter. Now my camera, I played with it, it actually does it at the beginning and the end. But basically a rear curtain, your shutter opens, it holds for a long time, and then it flashes right before it closes. Here's the purpose of that. When you're using the rear curtain, the slow speed of the shutter will blur the subject's movement and create the trails. So while it's open for all this long time, you're getting these trails, and then right before it closes you get a flash of light at the end, and you'll capture the object sharply also. So you get a sharp object with trails behind it. Hopefully that made sense. Shall be fun to play. A dynamic, also known as wow photo. If you want to get dynamic photos, you include a moving or a blurred object and still objects in the same photo. That's just a little goal for you to try to get to be cool. Water. Shutter speed is often used with water, and we will be doing this in the next lesson. A high shutter speed, remember high we learned was 1/500th or more, will freeze the water, or it'll make it crystal clear. It'll make it sharp. It'll stop the water right in its movement. It also stops people in their movement, like in sports photos. A slow speed, 1/15 or slower, is going to blur your water and make it that dreamy effect that everybody goes, wow, that's so cool. So this is what our next lesson is going to do when we have our hands-on shutter speed lesson. So for this lesson, I hope you learned a lot, and I know it was a long video, but it took me a long time to prepare. It took me a long time to think and learn all of this better in my mind so I could teach it to you. So take your time with it, and your assignment is to create the chart. I'm going to provide you with a download and create the chart for your camera and learn a little bit more about your camera. Grab that manual if you have to. I look forward to seeing what your camera can do.